All right, boys and girls, welcome back to the drive-through on a special Case of the Mondays version of the drive-through, sponsored as always by the deli. Hungry? Stop by the deli. Make yourself a rare roast beef sandwich with some peppered turkey on a Hawaiian bread with sriracha mustard and some provolone. All right, here we go. This is 4-5, the Intro to Parallel Lines section, also known as the most random section ever. Okay? I'm not exactly sure. I haven't got a good idea, but basically this is a little buffer section that serves to you a reminder about a lot of things that you've already been taught, and it'll kind of push us forward. Really, it's a pretty easy section. Okay? So first, we need to remember three terms. A plane, okay? A plane is a flat surface. You can read the direction there, okay? You can think of a plane as like a parallelogram, but a triangle is also a sufficient way to describe a plane, so that if I took any 2 points in this plane and I made a line between them, that line would also be in the plane. So what that tells us is that the plane goes on forever in all directions. So a plane is like, it's kind of like the three-dimensional version of a line, if you will. But it's not three-dimensional, it's two-dimensional. But a line is just one-dimensional. Don't worry about that stuff too much. We'll address it. Okay, so coplanar then means that are objects that are in the same plane. So if I made this into an angle here, then both this green ray and this blue line would be coplanar. Okay? And then a transversal is a line, a segment, or a ray that intersects two other coplanar lines. So you are used to seeing transversals written like that, where this thing right here is our transversal. And we're going to show you that more on the next page. So, in here, our red line is our transversal. But hopefully I know what you're thinking. See, these blue lines don't appear to be parallel. So, in essence, all of these lines are transversals. Okay? Now, what we're going to do today is we're simply going to identify some things that you already know about. But we're not going to talk about whether or not they're congruent or not. Okay? So you're going to recognize these terms, but we're not dealing with parallel lines yet. So we are not dealing with any congruent or supplementary angles yet. So, let's list some corresponding angles. Let's list some alternate interior angles. And let's list some alternate exterior angles. Okay, we are not going to say anything about their congruence because we don't think that these blue lines are parallel, okay? But 2 and 6 would be corresponding angles. 4 and 8 would be corresponding angles. Okay? 3 and 7 would be corresponding angles. And 1 and 5 would be corresponding angles. So, what does it mean to correspond with? It means to match up in this case, okay? And so you can see that we would call 2 like a top left angle, a top right angle, and that's going to match up with this top right angle. And 4 is going to be a bottom right angle, and it's going to match up with 8 because that's a bottom right angle. And you would call 1 maybe top left, and it's going to match up with 5, and then 3 is bottom left, and it's going to match up with 7. Okay, so that's how we address corresponding angles. Now, within our diagram here, we have an interior region and we have an exterior region. Hopefully you guys are good enough at your vocabulary language to realize that that yellow section here that I'm highlighting, that is the interior region. It is between the two lines that are being intersected by the transversal. Okay? Well, that means these two sections are the exterior regions. So the alternate interior angles are on the interior region, and they're on different sides of the transversal. So that would be 3 and 6 would be a pair of alternate interior angles, or 4, oh dear, or 4 and 5 would be a pair of alternate interior angles. Alternate exteriors then would be 1 and 8 and 2 and 7. Okay. Again, random. We're going to keep it random. All right, so this is our final part of today's new section, and it's about parallel lines, and you're probably like, geez, this is so easy. This is actually something that, I don't know, 30% of you guys are going to get a question involving this wrong on the test. It'll probably be an always, sometimes, never question. And the question would say something like, if two lines do not intersect, then they are parallel. And most people would say that that is always true. So I want you to look around the room right now. Okay, and I'm going to draw our room from an exterior view, because, you know, I'm an outside of the box type person. I don't even really know what that means anymore. I think outside of the box is officially an overused term. I think we need to think outside the box when we're coming up with a term that describes thinking outside of the box. Okay? No? That's what I think. All right, so parallel lines. Parallel lines are coplanar lines that never intersect. So you would say that the line that touches the front wall with the ceiling is parallel to the line that touches the front wall and the floor. Okay? Those lines are parallel because they are coplanar. What plane are they in? They're in the front wall plane. And do they ever touch? No. Niet. Okay? But here's where you got to pay close attention to the definition. I want you to think about the line that meets the back wall and the side wall. Look at that line in the room right now. And I want you to compare that to this line again that is the front wall and the floor. Will that red line ever intersect with this yellow line? It will not. But are they parallel? They are not parallel. Those two lines are called skew, and we'll talk about that at some point. But what you need to know is that if the lines are not in the same plane, then it's hard to tell if they're parallel or not. So remember that. Lines cannot intersect and cannot be parallel. And that's kind of the only tricky thing from the section. Can I get a boom, Ace Bell?